I'm delighted this morning to be joined by Demis Hassabis, the CEO and co-founder of DeepMind. Demis has led an absolutely fascinating career. He's a former chess prodigy, the recipient of a double first at the University of Cambridge, a 5-time World Mind Sports Olympiad champion, an MIT and Harvard alumnus, and a teenage entrepreneur. Today, DeepMind is one of the world's leading AI research companies and is best known for developing AlphaGo, the first program to beat a world champion at Go. DeepMind's published over 1,000 research papers, including more than a dozen in Nature and Science, and achieved breakthrough results in many challenging AI domains. Demis, welcome. Great to have you with us today. Thanks for coming in person.
No problem. It's great to be here.
Thank you so much. So last time we met, we talked a lot about the way that DeepMind is now moving into science and is now thinking about how it can impact, how AI can impact scientific research. So I'm interested, really, can you just describe that sort of that move to us?
Yeah. Well, I mean, it's always, when we started DeepMind, and actually even before DeepMind, for me, the ultimate vision of building AI was to try and use it as a tool to understand the world around us better. That's what I was dreaming about when my teenage years, when I first got into AI. And I've been working towards that my whole career, and obviously DeepMind for the last 10 years. And what's exciting now is that maybe we've got to the point finally where our algorithms are powerful enough and mature enough that we can actually apply it to big scientific challenges and maybe help accelerate scientific discovery. So, you know, we're kind of most famous for our work on games, things like AlphaGo, as you mentioned, but really that was always just a proving ground for developing and testing and sort of proving out these algorithms efficiently. And then the idea was to transfer them to things like science.
And how do you think that scientific research is best organised in order to get optimal results?
Well, I think there's different ways to try and organise scientific research. The main one, academia, which obviously I spent quite a lot of time in, is mostly bottom up, I would say. So the creativity sort of bubbles up from PhD students, postdocs, and so on, and it's kind of a creative chaos, let's say. And then on the other hand, you've got companies, startups, the best startups, which are mostly top down. And the great thing about those is they come with a lot of energy and pace and focus and intensity that you get with the best startups, as you know well. And I've always wondered why, and I've been lucky enough to be in both worlds, why you couldn't combine the best of those two worlds and have a kind of, blue sky research group or division, but with the same intensity you get from a startup kind of mentality, and that's what we try to do at DeepMind.
So in academia, generally, you hire the smartest, or you recruit the smartest people you possibly can. You put them in a lab. You say, "See you in 5 years," and you close the door.
You hope for the best, close the door, and when you open it 5 years later, maybe you have something, maybe you don't. And it's not very coordinated, so it's not that efficient in many ways, because as you say, in the top places, top universities, you have some of the smartest people in the world there. So the ingredients are there, and you give them time to think and so on, but there's no sort of macro coordination between, beyond the kind of small lab level. Like each lab is maybe coordinated, but there's no coordination on a bigger level than that. And in fact, it's designed for there not to be. And so, it makes it hard to really go after massive breakthroughs in an intense way over multi-years, especially if it's interdisciplinary. So there's some things like that are quite hard to do actually in academia, I would say.
I think the interdisciplinary bit's interesting because, as far as I can understand, what you're doing at DeepMind is trying to build teams that have multiple sort of areas, domains of expertise.
Absolutely. So obviously our core thing is machine learning, but we also have neuroscientists, we have mathematicians, physicists, and of course engineering. And engineering is our kind of workbench, if you like. If you the engineering it makes it an empirical science. And obviously we have some of the world's top engineers. But in academia, for example, if you're working in computer science, there isn't actually, weirdly, there isn't a career path for engineers. You have to be a research scientist, and then you've got the traditional PhD student, postdoc, and then you've got to try and make it to assistant prof. But if you want to be a career engineer in academia, there isn't really a sort of defined career path. So you obviously end up losing some of the best engineers out of that. So there's many sort of strange things like that would be odd to somebody who's not used to academia. Like, why does it work like that? It's just kind of the way it's always worked.
And how do you get those individuals in those who have deep expertise of a particular domain to kind of communicate with each other.
Yeah.
A biologist isn't always going to be able to speak to a chemist
No.
or a mathematician or a computer scientist.
Right. That's the absolute hardest thing. So first of all, you need to hire people with curiosity, and also I would say a bit of humbleness, because it takes some humility to approach someone else. Say you're a world expert in one of those domains, right? And then you're relative beginner in these other domains. And it takes some vulnerability and humility to go to someone else who's super expert in that other domain and kind of explain you don't know that much about that when you're used to being the one that explains your area.
Sure.
And I feel like that's one big reason why there aren't that many true interdisciplinary people, because it's quite hard to the ego to go and do that. I mean, I experienced that when I had a whole first career in computer science, and then I went back to university to do my PhD in neuroscience, and I was starting as a beginner again, and sort of the bottom of the pile after 7 years of running my own games company, and so it's quite it takes a certain sort of psyche to be able to deal with that. And then on the other thing is what we look for actually at DeepMind is, and I try and hire for, is what I call sort of affectionately glue people, which is people that really are sit in that intersection of one or more subject areas or disciplines and can do that translation, spot the connections. And then you don't need everyone to be like that. You just need a few people like that, and who can operate at the level where they can understand and explain things to the other world-class experts in their more narrow domains, and then make the connections for them. And sort of say, you should talk to this person really, because what you're actually talking about is similar. And I'm that's one of the things I do actually at DeepMind is to try and be a generalist and make those connections.
Yeah, I was about to say, there are many glue people out there. They must be quite hard to find.
They're really hard. I would say we have, maybe out of 1,000 people, like a couple of dozen of those. Right. So they're very rare, and it's rare because it's a bit like a decathlete. Decathlon sort of. It's hard. The whole way that academia is structured. It's hard for those interdisciplinary people, because usually when you get evaluated for a position or a grant, normally you're judged by an expert panel in your nominal subject, and they don't care or know about these other extraneous things that you know about, which are these interdisciplinary part. So you sort of have to compete on the narrow domain with the other people who are only doing that, whilst keeping your general interest going. So it's quite a lot more work and a lot harder to do that.
So one of the areas that you're really working hard on, I know at the moment, we talked about it when we last met, to discuss the wide feature, was protein folding. Just give us a sense maybe for the audience on why you felt that particular challenge was one that you wanted to sort of like apply, DeepMind's resources to.
Sure. Well, when we go after a big problem like that, there's a lot of evaluation we do beforehand. So partly one of the main things, first of all, starting points is to make sure the problem is a big enough impact. If you were to solve it, if you're going to spend 3, 4, 5 years trying to solve something, you better make sure that it's something that would unlock a lot of new potential. And secondly, we also look for things like properties of the problem. Do they suit the types of algorithms we're building? So the kinds of things we look for, is there enough training data? Or is there simulations we can create more synthetic data from? Is there a clear objective function that you're trying to optimize? Some clear metric that your AI system can hill climb towards. And then we also look for things like clear external benchmarks, maybe a competition or something that runs by the community that you're going into that you can clearly measure your progress against. And protein folding ticked all of those boxes. So it has some data. It has some great competitions. This thing called CASP every 2 years, which is a community-run competition where you have to predict the structure of a protein before it's revealed by experimentalists. So it's a fantastic competition. And in terms of how important it is, I mean, proteins are essential to every function in your body. So it's key for disease. And so if we could understand the shape they fold into, then maybe we could accelerate things like drug discovery. So clearly, if you could crack that problem, it should have a lot of downstream impact.
You mentioned CASP. I know there's one going on at the moment. Clearly, you can't sort of like talk about, any kind of, insider knowledge you might have about what's going on. But like, that's a really important proving point, isn't it? Because it shows the research going in the right direction.
That's right. And CASP is this incredible, it's in its 14th edition now. So it's been going since mid-90s. And yes, we've sort of, the announcement, actually, the results are going to come out next week, and we think we've done pretty well, but obviously we can't, it's confidential until the results are officially announced. But it's a great example, I think, in science of one of these really rigorous benchmarks that have been run, and it's fantastic for allowing the field to progress and making sure that you really are making progress towards the ultimate goal, not kind of kidding yourself on the way somehow that your internal metrics are one thing. Obviously, you're always measuring how good are your algorithms internally and your own benchmarks. But there's nothing better than like an external measure that's judged by an independent assessors to really test your mettle.
Well, we're going to be looking out for those results next week. We can't have a conversation in 2020, obviously, without talking about coronavirus. So I'd love to get your thoughts on whether DeepMind's been working on this particular challenge and how machine learning, as far as you know it, has kind of played out and had an impact on drug discovery or what we understand about the pandemic.
Yeah, I mean, so us particularly, I've been working on it both professionally at DeepMind and also on a personal level as a scientist. At DeepMind, what we've done is actually very early on, the COVID virus was sequenced by, I think, some Chinese researchers, genetically sequenced. And so what we did is we used an earlier version of AlphaFold, which we thought was pretty good already in March, to basically look at the structures of some of the proteins in the virus that were understudied. A few of them we already know the structure experimentally, but some of them we didn't. And we put our best predictions out, open source that to the community straight away, so that people could use it and maybe target against that. But we didn't make a big claim about that because at the time, obviously, the CASP competition hadn't been run yet. That was run over the summer, so we hadn't had external validation of how good our system was. We thought it was pretty good, but we didn't want people necessarily to rely on that until it was externally validated. So God forbid if something like that happens again, in a future pandemic, 3, 4, 5 years, I would imagine AI playing a much bigger part than it did this time around, where I think in some senses it came a little bit too early for AI to be at the forefront of obviously what the great scientific effort that's going on. And we've seen a lot of new hope in the last few weeks with the vaccines and so on. So obviously the whole scientific community's come together. And I think AI will be just one component of something like that in the future, but maybe a much more important component than it was this time around. And then on a personal level, I've worked with the Royal Society to try and put out studies on things like masks and the effect of opening schools and other things, bring together some of the top scientists in the UK to help write white papers to advise government.
So let's talk a little bit about this discussion around algorithmic sort of bias and data bias. Obviously, AI systems can amplify this in some ways. How do you think about that in terms of what DeepMind can do to sort of combat that?
Yeah, so this is a hugely important question. Obviously, we have a whole research team looking at this. We kind of put it under the rubric of fairness, bias, and interpretability. These are all key things that we need to understand about systems before you deploy them. A lot of what we do is pure research, so it's not. I think it becomes more pressing when you actually create a product out of your research, and then it's used in the real world to do something that affects people's lives. So a lot more research has to be done on that. We work on that. We also collaborate with places like Turing Institute and other places to sort of look into that further. And I think the next phase of development is going to be building analysis tools and visualization tools to look inside these sort of so-called black boxes of these neural network systems and understanding better what they do. And I think there we can take inspiration from how we analyze the brain using neuroscience and things like fMRI machines and so on. What's the equivalent of that for AI systems? And just on the optimistic side of this problem is that, of course, humans are biased in many ways ourselves. And if we build the AI systems wrong, it will they will amplify the biases we already have, or designers and other people already have. If we build it right, then potentially the AI systems could be less biased than we are as individuals. So I think it's a bifurcation. If we do well with it, I think it could actually make the societal problem of fairness and bias better than it currently is.
So clearly we've had a global pandemic. AI is also a kind of like a global technology, and to some degree there's a lot of competition going on to sort of advance research as quickly as possible. We have obviously China and the United States. The UK is going to be very important obviously for us, as we kind of embark on our post-Brexit sort of like journey. Where do you think we are in the UK, and how best can we kind of push sort of deep tech forward and really become a centre of excellence, do you think?
I mean, I think that the UK, we've always punched well above our weight in terms of pure research. So we've got world-class universities. We always have several in the top 10 in the world. And if you look at other measures like Nobel Prizes or citations and big papers, we do phenomenally well. I think that the UK needs to really cherish that and build on that for starters. And that includes like post-Brexit, making sure we're still plugged into all the European sort of frameworks on research frameworks, because we generally get more grants than we put money in. So that needs to continue somehow, and also keep welcoming the top talent here. In terms of AI, obviously, DeepMind's still here. We're located here with pretty much all of our staff. There are many, I think we've helped create a big ecosystem in the UK now of AI startups. So I think we do very well on that. So I think there's a lot going well. We just need to carry on building on that momentum and investing in things like scholarships for underrepresented groups to broaden access to AI technologies, and to deepen where we're strong. In certain universities, maybe increase grants to those and so on. From a government level, we're doing that as DeepMind, like sponsoring a lot of master scholarships, and also I do that philanthropically as well in my own personal way. So I think all of those things are going to add. And I think in the future, you've got the UK, you've got places like Canada, France, where there's actually a lot of good AI work going on that maybe could act as a counterweight to the two superpowers. I think in general, let's say you take Canada, UK, and France together, probably that is as there's a much going on in those three countries put together as there is in those two superpowers. So I think there's a lot of opportunity for the UK actually to have a big voice at the table, a big say on how this goes.
It's good to hear that optimism. So let's maybe take a look at some of the questions coming in from the audience. We've been talking a lot this morning about sustainability. How do you think AI and DeepMind in particular can kind of have an impact on clean tech, which seems to be an area that is really developing very quickly?
Yeah, I think it's one of my passion areas actually. Is for I think AI has a lot to play, and we've done quite a few projects already. Actually, our more sort of applied projects. Two of the better known ones are applying our AI systems, actually very similar ones to AlphaGo, to control the cooling systems in data centers. Data centers use large amount of energy. Actually, Google's ones are mostly renewable energy now, which is great. But even still, we save 30% of the energy used in the data center by just more efficiently operating the cooling systems. There's hundreds of different switches and pumps and fans and things you can turn on, and AI is perfectly suited to managing that. And then we've developed that further recently as a service on cloud, Google Cloud, to we call it sort of building adaptive controls. So big industrial buildings, office buildings, I guess not so much now during COVID, but in normal times use a huge amount of energy, right? Again, with the air conditioning and heating and all of that stuff. And it's the same kind of principle that we use in the data centers, but now in terms of controlling all the building systems that govern climate, temperature, and all that sort of stuff. And that saves a huge amount of obviously money, but also energy by more efficiently running all those systems.
Sure. Another question coming in from the audience. There was one about neuropsychology. How influential is it when developing AI solutions? An area I know that's obviously dear to your heart.
Yeah, so it's actually very influential on a certain type of level. So what we're not trying to do when we say we're neuroscience inspired is we're not trying to copy how the brain works, right? Like reverse engineer it. Some people are trying to do that, but we don't think that's the right way to build AI, because of course there's massive differences obviously between a carbon-based system like our brains and a silicon-based system like a computer. So the implementation details will be different, but what you're interested in is the principles of general intelligence. So the architecture, the representations, and the algorithms. And so we call that systems neuroscience, and that's where the level that we look at neuroscience and psychology at to get inspiration.
Okay. Thank you. Another question around how you balance, the work for Google and Google products. Clearly, you have to deliver sort of products for Google. How best to balance that relationship?
Yeah, very big. I mean, you can think of it as they're our biggest client in a way, right? If you think about all the different things we do, and so it's obviously we've actually had 100 product launches now within Google. So when you use Google devices, you may not know it, but most of the time you'll be using some of our tech will be under the hood. Probably the best example of that is WaveNet, which is the world's best text-to-speech system, and we developed that a few years ago and scaled it up, and now pretty much any device you speak to on Android or Google device anywhere the voice that's speaking back to you will be WaveNet, our technology. So that's just one example. On the other hand, obviously, we do a lot of other partnerships, and there are a lot of other work that we do that's outside of Google, especially in the scientific realm. So it's quite a nice balance. And one nice thing about Google is that when you build a product, when you build some research and you discover something new, you can straight away put it in a product that reaches 1 billion people. So that's fantastic for impact, and also for getting back sort of real world information about how good are your algorithms really, once they go out of the lab.
Yeah, absolutely. Once the people are actually using the product.
Using it at scale.
Absolutely.
Yeah.
So a final question from the audience. Synthetic data can be tricky. How do you manage that avoid issue, including biases?
Yeah. Well, synthetic data, actually, interestingly, I mean, we're experts in synthetic data because we started with games and virtual worlds and where we generate all of our own data, actually. And one reason I did that was when we were a startup, obviously a small startup, we had no customers and no data. So how would we compete with big companies that had obviously all their consumer data? And one of the answers was to use games and then generate that ourselves with like Atari games and run the simulators and then generate our own data.
Yeah.
So that was one of the, I guess, the founding principles of DeepMind. One of the reasons we chose games, obviously, is also my background in games. So, but of course, as we've now matured, you've got to be careful with synthetic data that you're not generating it in a biased way. But just like we discussed with fairness and bias, it's also the optimistic side of that is that if you generate synthetic data, you can mathematically analyze it and make sure that it's not biased, right? Which you can't really do with real data because you just have whatever data you have.
Yeah.
So I think synthetic data has the potential, if you analyze it in the right way, to be more balanced.
Okay, one final question. You're a chess prodigy. Have you been watching The Queen's Gambit? And if so, what do you think of it?
I have. It seems like me and the rest of the world. And I watched it actually as soon as it came out. Of course, how could I not, given it was about chess and it was such a great story. I thought it was fantastic. And I actually thought it was extremely realistic portrayal in many ways of what it's like to be a child chess prodigy and the exhilaration of it, but also the pressure, perhaps minus the psychedelic drugs. But I mean, and the chess was extremely accurate, which is unusual in films, but I guess it's because Garry Kasparov, I found out afterwards, was a consultant on it. So I guess he made sure that the chess part was really accurate. Well, but I recommend it.
Well, if people out there aren't watching the DeepMind documentary on Netflix, the Queen's Gambit is the second best. Demis, thank you so much for joining us. Really delightful to have you here at Wildlife.
No problem. Thank you.